talking about the slab.
But I think they did unfortunately for things, but it was just not a big deal. Right?
There was one class video that I recorded, I had it set up right, and I thought, oh, it's just slightly off, let me adjust it, and when I adjusted it, I put something in front of the part which gets depth perception, so the entire class was blurry because I adjusted it.
Oh, no.
And I think about that as I just adjusted this, whether the whole thing's gonna be blurry or not. All right, so sorry I didn't have something posted for today for the lab. Part of it is I'm still getting used to we're doing this in half the number of weeks, and the pacing is still odd to me. And part of it is on me. But there is a feeling, a gut feeling of, oh, I got plenty of time. All right, so we'll start out with, are there any questions? Ariana?
I have a question about the lab.
Yes.
For question 8, I wasn't sure about the acceleration versus time graph, what that would look like. I was talking
What's
to
eight? That one? So recognize that that I gave you position versus time, and recognize that if I do the slope of it, that's my velocity graph. And then similarly, slope of velocity versus time gets us acceleration. And we talked about that last time. And it's all based on the idea that, actually, it's based on by definition. There's no inherent reason why this is true, other than the fact that the powers that be, when they define position, velocity, and acceleration, they defined it so that this works. But from our point of view, the fact that velocity is the change in position over the change in time, which if we have a position time graph, is basically rise over run. That's my change in position there, and that's some change in time. So, if I have a graph that looks like that, where is the slope equal to 0?
At the little peak of motion or bottom of motion.
At the bottom?
At the either top or bottom of the.
Okay. Oh, and as a special guest, we are recording this, just so you know.
Okay.
Mike,
Do I get royalties?
yes, I will
Okay.
give you 1% of all that I make off this.
Awesome. So, hi, I'm Mike. I'm a tutor here. I don't know, raise your hand if you've used tutoring at all, far? Okay. Does everybody else know it's free? Yes? Okay. Do you know that we have a drop-in lab? No. It's right there, all right? So if you need help with physics, there's myself, an older guy, Fred, and another guy in there, Stuart. Me and Stuart, we both had him. We understand the eccentricities of his mind, at least more
As best as anyone can.
the average person, yeah. The best a mere mortal can. So if you need any help, you don't want to do like a one-on-one session, because sometimes it's hard to condense it into an hour. You can go right into that room, you put in your student ID number, and you just sit down and ask for help. And as long as we're open, there's basically someone in there that can help you with this class. Because with the 8-week thing, I'm sure some of y'all feel like, hey, we could use some help. So yeah, it's free, open, from I think 8 to 7, Monday to Thursday, and then 8 to 5 on Friday. And we actually enjoy physics, don't judge us for that, so don't
Good.
feel like it's a burden or anything like that, that you're coming in, you know, you wanna sit down and work on it for 3 hours, we're up for that, okay? Any questions?
Just
Anybody?
throwing, Mike had me for 251 and 252, the calculus space course, but he's been tutoring here for how many years, this way? 4?
3 or 4?
3 or 4, okay, so.
I'm bad with time.
4-ish. Stuart had me for 110 and then went on to be a physics major.
Yeah.
At Charlotte State?
He was properly brainwashed, State.
State.
Yeah, I went for chemical engineering, I, bucked the trend, I know.
But both of them, if they have questions, will come and talk to me.
Yep,
That-
I did it as a student and I will continue to do it, yep.
Indeed.
Alright, so, everybody good? Cool.
Thank you.
Anybody? Yep, you're welcome.
All right. So when you have a curve, if I want to find the slope at a particular point, since it's not a straight line, it's hard to do rise over run, you draw a tangent line. So as best you can, the tangent line just skims at that point. I guess I did the tangent line for that point. And you find the slope of the tangent line. So for something that's curving up and down like that, the slope is 0 when the tangent line has a slope of 0, which is a horizontal line. So no matter what that graph is, the slope graph is 0 here, here, and here. Then the next bit is to figure, well, is the slope positive or negative? So in between these zeros, is it positive or negative? Is the slope going like that, positive or negative?
Negative.
I think somebody said it.
Negative. Negative.
All right, so somehow I have to get from this point to that point in the negative region. And then in this region right here, positive or negative slope.
Positive.
So I have to get from this point to this point on the positive side, and it looks something like that. Matter of fact, it would keep going, if that keeps going. And then, so now I have a graph that, well, actually it's positive there, so this starts out on the positive range, so we're trying to somewhat reproduce that. That went far. And now the slope of this one. Where is this slope equal to 0?
At the top and bottom of like the fence again.
Same basic rule, there and there. In this first region, positive or negative?
Negative.
Next region,
Positive.
and so it's going to just end up doing that. Which is, so those are the, so just looking purely at the slope aspect of it, that's how you would do it. So I think the first one starts, it's basically from here to here. I'm off there, so that should have been. Graph paper would have been really cool there. That peaks. I'm gonna redraw that one so it actually lines up better. 0, 0, 0, and then. So in this particular one, you're just looking at this part right here, and there's the, for the math fans out there, the derivative. But that, this is position, that's velocity, and then over here, we are starting at 0 and going to 0. So that's basically, if that's my velocity graph. I cannot draw directly over one. So 0, 0, So if that's velocity, that would be the acceleration.
Thank you.
And this is just basically the first one upside down. Now, from a more conceptual point of view, I mean, this is the slope aspect of it, but remember that if my position time graph looks like that, what is physically happening to the object?
It's not moving.
Right, because the position's not changing, that is a constant position. So I start out, so the closer it is to horizontal, the slower you're going. So at this point, we're not moving, but then we start moving in the negative direction, because we're heading downwards towards the origin. So we're moving in the negative direction, but we started out slowly and we speed up. Now we're stopped at this point. This is a turnaround point. This is when you're going from moving towards it to now moving away from it, but you have to stop for a brief moment as you change directions. So you speed up, go in the negative direction, then you slow down, and you stop very briefly before you start speeding up in the positive direction, and then you slow down again. So physically, you're in essence doing this motion. And for some groups, I did that while you were doing the lab, where when you're trying to figure out when it's possible for, it was the first big table, the positive position, and then either plus minus or zero velocity and plus minus zero acceleration. And I basically moved the object right in front of the sensor, because you can find each of those aspects within it. Other questions? Or more questions?
I have questions on the master set, 4 and 5.
Yes, ma'am.
Okay, so on 4A, it says, what is the magnitude of the total force acting on the box? And so it gives you the two forces. It says 50 newtons force adding to the east and 120 newtons force acting north. So do you add those, or do you subtract them and say 70 newtons north? Or do you add them and just say 170 newtons total?
You add them, but you don't add them like scalars.
Okay.
You add them like vectors.
Okay.
So,
I know we already talked about it, it's just the wording, like I don't know when to add them.
total is a sum.
Okay.
Because I did say what's the total force or net force?
Magnitude of the total force.
Yeah.
Okay, so first off, magnitude means that in the end, I don't care what the direction is.
Okay.
I do care about the direction as I'm going through the process. It's only at the end I don't care what the direction is.
Okay.
And then magnitude of the total force would be a sum. And so then the question is, how do you add vectors? Because I think it was 50
East.
newtons east and the 120
Yes.
newtons north. I picked these numbers because it gives us a Pythagorean triplet. So what I'm adding here is, again, when you add vectors, head to tail, so take one of them, it doesn't matter which one. I picked this one. And then I now start here, and I go up 120, so that's 50, 120. And so the sum, the resultant, is a vector from where I began to where I ended.
Okay.
That's a right angle.
See, I was stuck between that or just adding them and then the caring about the direction with the 70 north.
So if it asks for the total force, we're gonna do Pythagorean theorem.
If they're at a right angle, if they're
Okay, I see what you're saying.
perpendicular to
Right.
each other.
I see what
Okay.
you're saying.
Perfect.
You would add them just straight. If I had them both going in the exact same direction, then you would just add them straight up.
Okay.
170 newtons.
All
If they're
right.
going against each other,
Or an
then, if they're opposite each other, then I'm gonna subtract because they're opposite each other. But if they're at the right angle to each other, Pythagorean theorem is in your future.
Perfect. Okay. All right. And then I had a question about 9. 9 is just really confusing.
Yeah, can we do something?
All right, what was 9?
It's about the elevator.
Would you want
I
me to
don't know
read
if
the
that
whole
rings
thing?
any bells.
Yes, please, read it.
Go ahead.
Okay. A 100 kilogram man gets in an elevator on the 10th floor. He stands still on a scale which is placed on the floor of the elevator. Before the doors close, the scale reads a value equal to his weight, the largest force of gravity on him. The doors close and the elevator starts moving downward toward the first floor. The elevator speeds up until it reaches the 8th floor, at which point the elevator travels at a constant velocity, which it maintains until it reaches the 3rd floor. At which point it starts slowing down at a constant rate and stops by the time it reaches the 1st floor. Rank from greatest to least the following quantities at the following floors: the 2nd, 5th, and 9th. And then for A, his mass, equal, because it doesn't change, correct?
Right.
Okay. B, his weight. C, the magnitude of normal force he exerts on the scale, and then the magnitude of normal force he exerts on the elevator floor. So we're ranking the 2nd, 5th, and 9th floors, from greatest to least.
Okay, all right, so it gets in on which floor again?
The 10th floor.
On which?
10.
10th, all right, so 10, 9, 8, 7, 6, 1, all right. And so it gets in, and then out down here. Presumably he gets out of the elevator.
Presumably.
So it speeds up till it gets to the 8th floor, right?
Elevator starts moving toward the first. Yes.
And then he slows down from the 3rd floor to the 1st.
Yes.
Well, it says a constant velocity, which remains until it reaches the 3rd floor.
All right, so from 8th to 3rd, it's constant velocity.
And then, yeah, we're slowing down.
Reaches the 3rd floor, slows down.
What was that last thing, Bailey?
It's slowing down. It says
At
at
the
which
3rd
point
floor.
it starts slowing down at a constant rate and then stops by the time it reaches the 1st floor.
Okay, so basically this is the scenario we've set up here, that he gets in, it speeds up because it has to get up to speed, he then is cruising, and then he slows down. So basically, an incredibly complex drawing of man in elevator. First off, there's one little bit of just side note, 100 kilograms. How much is it? Is that a large man, small man?
Large.
Large, small are all relative. Just to give you some idea, because occasionally I see people put in things on labs, like I put 100 kilogram mass on the spring or something like that. My mass is about 100 kilograms. Pardon?
It's like 200 pounds.
Yeah, I'm a 220, it fluctuates. The last time I went to the doctor was 213.
Sure it was.
But anyway, just give you some sense of, this is what 100 kilograms looks like. Or just shy or just above, depends upon the time of year. All right, so the force, let's do a force diagram. I got person, I have scale, I have elevator, and I have ground. We have our checklist. So, what force is acting on what object? And in which direction?
Well, he's acting down. He has a, I don't wanna say it wrong. I guess it's
What?
the gravitational, I don't know how to explain it. He's acting down.
There's normal
Almost
force
down.
between the
Alright.
scale and the man.
Okay, there is normal force between scale and man, and Bailey, you're almost there.
I don't know, I don't have the right wording for it.
Give us the W.
The weight.
There we go. Or gravitational force, or force due to gravity, but weight
Force
specifically.
force due to gravity.
Yes,
That's what you wanna hear.
actually, I'm fine with weight here.
Okay. Alright.
But I appreciate your not wanting to just say gravity and leave it at that. All right, so weight acting down on,
It'd be the ground. Or the scale. I don't know.
The earth,
what did you say?
the earth, the earth.
Acting down on the earth?
On the man.
All right, so I'm getting a lot of mixed messages here. Someone from a different column. Which way does gravitational force, which way does the weight act on the person? Okay. If you think about it, if he suddenly stepped out of, somehow magically, the elevator and the scale disappeared, what would happen to him?
It would fall.
Yes, because there's something pulling him downwards. So there's a weight of a person there. Forces come in pairs. Where's the other part of that pair? I think I just heard it said, acting up. The gravitational force is on the big planet, on the planet or the moon or whatever causing the attraction, is going to be upward. So it's up on the planet, down on the person. And then I also heard scale, down on the scale, up on the ground. Any other weights?
The elevator on the ground.
Weight of elevator. All right. Those are all, we had 3 small objects compared to the Earth. All right, I heard normal force between man and scale. Which way is it acting on the man? It's a support force. Vertically, it's holding him up. Normal forces aren't always vertical, so right now I'm leaning against the wall. I have a normal force pushing that way against me, keeping me from falling into the bathroom. So I got normal force on person and then down on scale. And what else?
Would you have a normal force between the scale and the elevator?
Yes, you would. Which way is it acting on the scale?
Upwards.
Darn straight. Not weight, normal force. And then. Now there's something holding the elevator up that's really not part of the problem that we care about, but there's got to be something holding up on the elevator because I got these 2 forces acting down on the elevator, and I think we're assuming the elevator is not in free fall because it would not do the speeding up, constant velocity, slowing down bit. So.
Tension of the cable.
Yeah. So tension with the cable there, and there's going to be some tension acting up there, and we're going to just stop that right there because then you have to go into, is the cable attached